Hello and welcome everyone. Thank you for joining us today for our webinar titled Further Exploration into Model Explainability with H2O Driverless AI 1.9. My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Ben Cox is the Director of Product Marketing at H2O.ai. Before I hand it over to Ben, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar with time permitting. This webinar is being recorded. A copy of the webinar recording and slide deck will be available after the presentation is over. Without further ado, I'd now like to hand it over to Ben.
Hey, thanks, Shabar. Thank you, everybody, for taking the time today. As some of you may know, we're kind of doing some of these to give folks some insight on what's new with 1.9. We spent a lot of time on driverless AI and building out this platform to really give data scientists the best toolkit and platform to really optimize their end-to-end workflow. So as Shabar mentioned, my name is Ben Cox. I'm Director of Product Marketing. I focus a lot on responsible AI, machine learning explainability, machine learning interpretability, and all of the kind of other, fate considerations, fairness, accountability, transparency, and ethics that go into deploying machine learning models in production and, playing for table stakes, right? So our MLI toolkit is pretty robust, and we've put a ton of time and effort into it. So our goal today is kind of to walk you through what's the latest and greatest and what we've been focusing our efforts on lately. It's worth noting that this area of interpretability and explainability is an evolving animal. You'll see that later on we'll talk about a couple of new, leading edge algorithms that we added into our systems to enable people to use the best possible explainable modeling methodologies available. And we just take this type of stuff to heart. So hopefully I can walk you guys through and tell you what we've got, what we're looking at doing in the future, and some of the things that might be able to affect your business in a positive fashion. So let's just start off on some of the things that were partially in the last release and really formalized now. I think folks who are using ML at their companies have a big eye on fairness, right? Are certain groups of your customers being treated fairly with respect to others, right? For that, we built this tool called Disparate Impact Analysis. I think this is a methodology that many people know of, and one of our best fairness, discrimination, accountability metrics. It's really, really useful to determining, are women being treated disparately to men, and that type of question. And I think it's really, really important that as you go and start to look at productionalizing or, deploying machine learning at scale, that you have this insight to, are your models treating certain classes or variables the same as others, right? And a lot of times this comes up with sample size issues and stuff like that, which are all built into this, right? That we can say, look, there's not a big enough sample for us to say, with statistical significance. And it's these types of things that we want folks to have from an automated perspective at the end of their model development lifecycle, right? And I think what's really good about our MLI toolkit is that all of these things are automatically generated, and then you can tinker with them and adjust them and be flexible with these tools from there. This is a new kind of rehash that we've done, and I think this is a really important one. Sensitivity analysis. I think, Google calls it what if. I think that's another big way to describe it. And while this is a pretty, large, interface and UI, it's actually quite simple, right? When you make predictions in a machine learning model, there's a threshold, especially with like a binary classifier, right? There's a threshold of, are we going to put this prediction in one category, a yes or a no? Whether somebody's going to get a loan, yes or no? Will they churn, yes or no? And in this kind of chart, you can see that we do this threshold. And what you can do with sensitivity analysis, which is really, really interesting, is you can isolate sections of the population. You can isolate individual line items, individual characteristics, and then tinker with it. Increase somebody's income, decrease somebody's income. Did they miss their last payment? And see if any of these adjustments to, an individual line item or an individual prediction or a group of predictions would actually change it. This is really useful too because it's a lot of times you want to figure out what would have gotten them over the threshold. And I think this type of stuff is extremely important. And then it's also really good too because you can analyze the false negatives and false positives and see what are some themes that we see when we get it wrong or when the model gets it wrong. So this type of stuff is pretty critical. So another great one that we've kind of built out and will continue to build out is NLP, right? So one of the things that we do really well is when you run models and you have, some variable that's description or comments, Driverless automatically goes through and tokenizes those words and sees if those words have statistical significance to your model. Right? This is really useful when you're looking at sets like police reports or food inspections where there's all of these things that you're cataloging in terms of categories, this and that, but then there's some comment section describing what was actually seen, what actually happened. And you can see if there's some, textual themes over time. And having MLI on the NLP component of this type of stuff is great. This is one of the things that I use the most, and I find it super, super useful when you're looking at data sets and seeing what kind of themes come up from a text perspective and a more unstructured perspective. So new features in 1.9, brand new features. There's a couple really, really powerful ones that I think I'm going to try to talk to from a business perspective that I hope kind of resonate with folks. I think, our audience tend to kind of have a wide band of business leaders to data scientists to quantitative researchers, all the like. So I'm going to talk through where we're sort of coming from and what we built and why we built it. So overall, we wanted to sort of optimize, the UX. I think, as a platform company, as a software company, as an AI company, we want to continue to try to improve the UIUX for folks in a way that makes sense. So we changed kind of a new landing page and just kind of smoother GUI so you can kind of look at summary, DAI models, surrogate models, and then we definitely added in some new interpretation expert settings because I think, one thing to understand is that the amount of rigor on interpretation as of right now is not ubiquitous across industry or sector, right? Financial services will get regulated or be held to a different interpretability standard as, say, retail or CPG, right? So we want to give users as much flexibility as possible to get as explainable or interpretable as they need to meet the requirements that are being put upon them by oversight, regulators, that kind of thing, lawmakers, policy, et cetera. So we're working that through. Here's the kind of end-to-end list of all of the sort of things where, we updated or we changed, and I'm going to go through these in depth. And I think, if we have time for questions, that'll be awesome because I'm happy to answer things. But this is a really important update for MLI. I think contextually it's worth noting that there's been an aggressive push over the last 6 months, not just in financial services, but within the United States across industries to make sure that companies deploying artificial intelligence and machine learning that ultimately impact consumers are doing so in a transparent, explainable, interpretable, and accountable way, right? I think companies as they look to start deploying a lot of this awesome technology should do it with the caveat in mind that there will be a time where some oversight authority asks you to explain why a decision was made, and it doesn't necessarily need to be did this person get credit or did this person receive medical care on the extreme end, but why did this one consumer get targeted for a specific ad? And I think it gets important. It will become progressively important because I think we really are trying to learn why models are making the decisions that they are. And I think whether or not it's being held to a regulatory reason, I think it's just important as practitioners. You want to understand why decisions are being made by your algorithmic decision engine. So these sorts of tools are what we believe to be the best in class, and we'll obviously continue to evolve alongside the industry as newer, more effective methods are being put into place. So some of the details. This, I think, is one of my favorite. I came from a background of anti-money laundering and financial crime, and what happens in that is when you're looking at, say you try to make a purchase and your credit card got denied because they thought it was fraud, a lot of those, those systems that would block your cars from making a purchase because they think that, that can't be you, were rules-based systems, right? And I think a lot of rules-based systems are largely inflexible, and that's why machine learning and data science kind of came into AML and FinCrime and some of these things to overhaul it. Because, when this started is this purchase over $5,000? Is this deposit over $10,000? And these sorts of things that are just kind of arbitrary flags. What's really, really cool about this new piece in the MLI suite is that I'm sure you're familiar with our sort of surrogate decision trees and decision trees that sort of outline the decision path that the model took. We can now actually export it as a rules-based system in text, right? That's super, super important. That kind of stuff is absolutely critical because not all customers want an evolutionary learning machine model that continually changes the rules for suspicious activity reports over time. There's some compliance concerns with that. There's just some, growth concerns with that. How is this model changing? How much do we need to monitor it? But if you can export one really good rules-based system based on the current texture and distributions of your data, this new rules-based system, as defined and found by a machine learning model, using the latest and greatest methodologies, can give you a really current, nice rules-based system. And this isn't just with suspicious activity or financial crime. Rules-based systems still work in a lot of regards. And why this is awesome is because you can just build an AutoML model and automatically have a new, formalized rules-based system. And that's really exciting. I think this alone can drive a ton of value because not all companies are ready for ongoing production machine learning models to be generating their rules-based systems for, security fraud or, potential suspicious activity flags. I think this type of stuff is really, really useful because it's sort of where rubber meets the road of machine learning and business intuition. And I think if you're a type of machine learning practitioner and one of the things that you struggle with is explaining the output or the results or the interpretation of your machine learning model to executives or leadership or customers, this is a really good way to start to do it, right? I think this is a phenomenal method to start driving a ton of value with machine learning and meeting in the middle of, we're not ready for full automatic machine learning models in production at scale, but here's a great framework that we found at a point in time, and we can refresh it at a later date. But it's in plain English, and it's an awesome opportunity. Kernel Explainer, Kernel Shap is a further build out. I think Shapley values are the latest and greatest in understanding variables in your data set, and Kernel Explainer and Kernel Shap is a great build off of that, right? The simple intuition is in some models, we discover original feature weightings are being overweighted versus their relative weighting at the global level. I think this is an awesome, awesome methodology. I think variable importance, feature importance is critical, and I think Shapley gives you a deeper intuition as how and why things are getting weighted. Surrogate models on residuals, basically you want to pinpoint what variables lead to high model residuals and open the doors for model debugging, right? Essentially, if your model is getting things very wrong, you want to be able to understand why that's happening. And, surrogate models and, things like K-Lime, it's very good if you're using complex models to try to fit a simple model to it. One of the things that we try to push for at H2O is understanding sort of simplicity versus signal, right? I think, and I'll get more into this later, there was for a long time an idea that the more complicated the model, the more accurate it will be. And that's why kind of, deep learning really took off is the silver bullet in getting the highest accuracy. But that trade-off actually doesn't need to exist anymore. Like one of the things we'll talk about in a few minutes is explainable neural networks, which we're really proud of and I think provide a ton of opportunity to, add more white box models into your complex modeling pipelines. So enhancements to MLI for multinomial models. One of the things that we want to do is we want to be able to do MLI for, not just regressions, not just binary classifiers. We want to be able to deal with, multi-class problems. And then we're continuing to, build out are sort of leave one covariate out, right? I think loco models are also, having access to loco is also quite valuable. SMD and ME. So disparate impact analysis, which I talked about earlier, is continuing to grow, right? We're still trying to figure out, what's the best way to do it and how can we get better at it. I think, marginal error, we have it defined as the difference between the percent of the control group members receiving a favorable outcome and the percent of the protected class members receiving a favorable outcome. What's important to note in the way that I kind of think about this is marginal error is better for sort of classification problems or classification features, whereas SMD is a nice one for continuous features, right, like income or interest rates. And I think that these types of things are pretty critical because as we think about disparate impact, it's not just, education level, it's income level. There's these broad distributions. And I guess I'll stop here also to make a comment on this, right? I think that, we talk about adverse impact ratio, and one thing that comes up is as you become a company that deploys machine learning, you need to be able to understand and articulate this. I think a lot of folks who are active driverless users and customers come from financial services where they know that, Reg B and SR 11.7 and ECOA all require you to kind of give a root cause analysis why someone might have been, denied a loan, and that reason can't be because of any of these, protected class factors like education level, marital status, ethnicity, gender. These types of things are really important, and there's obviously a next stepwise process of, what features are highly correlated with those also protected features, right? And the thing is, and what we hope to kind of promote is for those who are sort of at the beginning of their AI journey, AI transformation, or AI, adoption curve, is to start here, right? Because what happens in the space, and this is just like a business commentary, is if you build out your AI or data science team based on, kind of very high-risk practices without focusing on the fate considerations or explainability and interpretability considerations, what you're ultimately doing is you're creating a bunch of technical debt for yourself down the road. So if you start from a best practices with respect to explainability and interpretability, you're saving yourself a lot of heartache down the road. Okay, so I think that there's two more things that I want to talk about in depth, and I think it's about two recipes that we brought in, right? I think for the longest time, we pushed to find the best modeling methodologies, and I think the addition in 1.9 of GA2M and XNNs is pretty critical. So what we try to do is as new methodologies come in, we build in these new recipes, or we build it into our platform. And I'm not sure how familiar folks on the call are with general additive models, but this is one of the more white box, highly predictive models that exist. And I think it's really important. I think these types of models where we added in, is going to be increasingly critical, and I think GA2M is one of the ones that Microsoft has added to, some of their open source stuff and some of their interpretable models. And, we think this is a very good step forward, right? Using these adversarial, interaction including models are very good for identification of, accuracy, but also with explainability. So the goal is we want to get as much accuracy as possible with the most explainability. XNNs. Yeah, so I think what had happened in industry for a long time was that, deep learning became very popular, neural nets became very popular, and there was this idea of, accuracy versus simplicity, and that was a trade-off you had to make, right? a deep neural network would always be more accurate than a general, a GLM. But what's great is with XNNs, that trade-off for tabular data is dead, right? You don't have to use some, very uninterpretable deep neural network with a million hidden layers and epochs. You can actually use XNNs, which are white box models that allow us to explain a lot of different things that are going on and the features that are making important decisions, right? And, from a structure perspective, they're very close to what we just described, right? The explainable boosting machines like GA2Ms or, the original GAMs of generalized additive models. So I guess at that point, I'll open it up to questions. I think we've kind of got through the lion's share of what I wanted to talk about. And if there are questions, Shavar, I'm happy to answer them.
Thank you, Ben. There are a couple questions. Can you explain the difference between LOCO and SHAP values for model interpretation?
Yeah, so it's tricky. I'll talk mainly about SHAP values because it's an area like I stay more close to. The way to think about SHAP values, and there's a really nice visualization on GitHub for this in more original kind of like Python notebooks and Thunderberg's at MSR's research. What's important to understand about SHAP values is depending on your prediction and kind of how the models are stacked on top of each other or how ensembles are built, certain features will be weighted differently. So I think one thing that happened is when we started building random forests and we started building, decision trees, we could very quickly do variable or feature importance, and a lot of people just took it as fact. But what happens is if you look at how variables are weighted with respect to one another, pushing you towards one end of a prediction, then pulling you towards another end of a prediction, it's very curious how those stack up, and they're not all the same. So the way to think about it, and there's a very good picture display of this that I think Microsoft has, and I think that can be found a couple places on GitHub, is if you think about the feature of, let's say, education level in credit decisioning, it will not always pull you in the same direction, right? And it will not always pull you in the same direction at the same weighting based on the other features. So if somebody is at a certain age and, the feature of education is weighted at some amount, if that person is 30 years older, education will sort of dilute in terms of how much importance that it might hold. This is a hypothetical, and every model is different, and some of these may not even be allowed in actual business space. But the way that I think about SHAP values is largely you just have to understand how features are weighting at the aggregate and at the line item level, and seeing how much for each prediction or how much for each model is it being weighted in a certain direction, because it's not always the same. And understanding that like getting pulled towards a yes and getting pulled towards a no for various features is a really good way to kind of visually imagine it. And if you go Google that, I think there's some really good explanations on it. It's a complicated idea. I still find myself struggling with it at times.
Great, thank you, Ben. Do you see potential of deep learning to be able to meet the needs of the financial industry, which is heavily regulated?
Yeah. Man, I want to say no so bad. No, so we joke. We make jokes that deep learning is good for two things, like securing venture capital funding and getting papers published. I think that XNNs are the industry and our attempt to bridge that gap. For the longest time, I come from a background in finance, and I think in credit decisioning, the most complicated you might see was a very shallow random forest or a very, very lightweight boosted machine. I believe that there could be a day where we get there. I think XNNs or GA2Ms are how we get there in the more deep learning space. I think that one thing that happens, and we're working on this now, right? One of the other releases with 1.9 is vision, right? Is computer vision. And, we're already spending a lot of time working on MLI for computer vision features. And it's just very, very complicated. And I know that we're a ways off of deep learning being accepted, but I would say that the trade-off here is, in fact, regulation will increase in severity. Meanwhile, deep learning will probably get more complicated. So there's these nice middle ground that we're hoping for, or at least that I'm hoping for. I'm not speaking for H2O in that context, but that XNNs or GA2Ms could actually be that kind of bridge, so that finance can get away from simple trees, simple boosted machines, and move towards more complicated models, but more complicated but white box models. Because what we found is the XNNs perform with tabular data the same as your typical deep neural networks, which that's really, really important. That trade-off of accuracy versus complexity or simplicity with tabular data does not need to be made anymore, which is pretty exciting. I know I'm pumped about that, because that's a trade-off that's very real. But also, as a practitioner, I would say firms should be looking to simplify as much as possible while maintaining signal, right? Because I think a public commentary of, in response to COVID, if you get into really deep learning, a lot of times what you're just doing is overfitting. And those don't perform well with anomalous events or scenarios like we're watching with COVID. So I think all companies should aim for simplicity with the appropriate signal trade-off. I think that's the best thing to do versus trying to get as complicated as possible.
Great. I think we have time for possibly one more question. Do you
Sure.
only support Shapley and not Lime, and others available out there?
Oh no, we have Lime. Yeah, Lime was one of the first things that we did and actually did papers and thought leadership on. It's just been such a mainstay for us that it wasn't worth mentioning on this call. But we have K-Lime and all the like. That's one of our favorite features as well. And let me make a comment here that all of the things I discussed today on this call is just recent things that we've rolled out or updated or refreshed. It's in no way all-encompassing of our MLI suite. It actually goes much deeper and would take a much longer session to discuss everything.
Perfect. Well, I think that's all the time we have for today. Thank you, Ben, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us. The presentation slides and the recording will be made available after this presentation is over. Have a great rest of your day, everybody.
Thanks, everybody.